Hi, I'm Teddy,
And I'm Colin.
and this is our introduction into limits. So, put in simplest terms, what a limit is basically just the behavior of a function for a given value of x.
All right, so this is an example function. The function f of x equals 1/2 x cubed. We're going to find the limit as x approaches 2, and it's written in this way in proper limit notation. This is read as the limit of 1/2 x cubed as x approaches 2. So we're going to look at the function, and we need to make sure that the left side and the right side of the function are converging on the same value in order for there to be a limit. So we'll find the value of x equals 2, and then we will find the value that corresponds to that in the y-axis, which would be 1. So the limit of 1/2 x cubed as x approaches 2 is 1.
Okay, so when solving algebraically for a limit, there's three methods you're going to have to choose from. The first of these methods, the most simple, is just direct substitution. This particular problem, in which it asks you to find the limit of this particular function as x approaches 1, the easiest method, direct substitution, is going to work out perfectly. So basically what I'm going to do is the x value wants to find the limit as x approaches 1. So what I'm going to do is just basically plug in that value. So I'm just going to do times 1. This is going to come out to 1, 3, and 3. So that's going to add to 7 divided by -1, which is obviously -7. So the limit of f of x as x approaches 1 is equal to -7.
The second example that we're going to show you is how to find the limit of a function when the denominator is going to be 0. So we're going to find the limit of this function, f of x equals x squared minus x minus 6 over x squared minus 9 as x approaches 3. So we'll factor the numerator and the denominator as shown here. These two will cancel out. So you're left with x plus 2 over x plus 3. Now we'll substitute in our value for x for the limit, and that will be equal to 3 plus 2 over 3 plus 3, which can be simplified to 5 over 6. So the limit of this function f of x as x approaches 3 is 5 over 6.
Now, it is important to note that in some cases, the limit will not exist. The way you know this will happen is if by the methods that you have learned to solve for a limit, the denominator will still equal 0, which will result in an undefined and no answer. So, like you can see in this case, it's asking for the limit of the function as x approaches 2. Now, this top function isn't factorable at all, so you wouldn't be able to cancel the bottom out, and if you substitute in the 2, you see 2 minus 2 obviously equals 0. You will get 0 in the denominator, and the limit will not exist for this answer. Also, keep in mind, the one method we're not going to go over in more depth, but you may want to use, would be to substitute very, very small values, progressively smaller and smaller, and then solving for the output to see what the function is approaching as you substitute these smaller and smaller values. For example, you could put in 2.2, 2.1, and then all the way down to something like 2.0001, like you can see here.
So now here's some problems for you to try. For these two, use this function f of x to solve for these two limits. For this one, you're going to have to use the conjugate method to get rid of this square root.